Welcome back. This next presentation is about phenolics in wine grapes. So we'll talk about what phenolics are, how they're measured, and provide some actual information on some trials that were done back in 2006 and 7 with some data, and the actual lab extraction process. Now, certainly year to year, data changes depending on the varieties, the age of the vineyards, irrigation, climatic conditions, all sorts of things. So every year is a little bit different, but the world of phenolics has not changed in recent years. How you extract them, the kinds of decisions you make. It's a pretty stable part of the wine and enology industries. So first of all, what are phenolics? They are metabolites of plants. In other words, products from the metabolism of plants using energy and going through the cellular chemical processes of growing and living. And so these byproducts that are created, these metabolites that are created, include these phenolics. And what are they made from? Amino acids. The essential amino acids make up proteins. You could think of a protein as a specially formed string of pearls, and each pearl is an amino acid, and the protein is the finished string that's folded into a particular shape. And the amino acids, the individual subunits of a protein, the pearls of a protein string, are essential for plants and animals. And plants make their own amino acids. They can't get them from eating like we do. We get our protein from eating plants and animals. A lot of people think protein, it must come from animals, but that's not true. Plants provide protein. All plants have protein in them. Dietary amounts of protein, though, significant enough to be a supply of protein for our diets, include things like beans, whole rice. Corn has protein in it to a certain extent. But there are a number of plants that have dietarily important levels of amino acids. And so these amino acids are common in all plants, and as these are metabolized or utilized, they have these byproducts called phenolics. And it's a wide group, over 4,000 known compounds that include this group. So what do they actually do in plants? UV protection. UV is ultraviolet light, so it's like sunscreen for the plant. Pigmentation. So some phenolics provide the reds in red wine. Pathogen defense. Phenolics are toxic to certain kinds of diseases, and they're inhibitors for certain types of arthropod pests like insects. And so they help protect the plant. And so they are a natural form of pesticide that is made by the plant. Some phenolics actually attract pollinators and seed dispersers, organisms that will come. They'll smell the phenolics, they'll detect the phenolics and come and either pollinate or eat the fruit that they have smelled and then spread the seeds in the process. Now, pollinators, remember, this is not just wine grapes we're talking about, but even wild grapes includes a lot of diversity in how they are pollinated. It's not always the same. Wine grapes, we're talking about wind pollinated, so insect pollinators are not important. But in other plants or in wild species of grape, pollinators being attracted by phenolics can be important. They are antioxidants in wine. So phenolics in the wine helps reduce the oxidation effect of the wine, and the wine is negatively impacted. And they're good for you. They're good for you. The phenolics in red grapes They add color, they add flavor and mouth feel. So the way the wine actually interacts with our mouth, the way it feels inside of our mouth is very, very important. And it's part of the overall wine experience, and the mouthfeel is part of that. The ageability of wines. When a wine is made, a phenolic analysis is performed, and it will be determined by the winemaker. When should this wine be consumed? When will it be at its perfect aging stage? Now, for white grapes, that's pretty quick. There is a very short aging process, settling and preparation process for the white wine grapes, but we don't age white wines in the same way that we age the red wines. Red wines might be intended to age a relatively short period of time because of their phenolic profile. And you go too long, you go past that relatively short aging, and it actually could deteriorate the desired flavor of that wine. Other wines might be intended to stay in the aging process for much longer until that phenolic profile reaches some optimum level. And so how long it should be aged is determined by the phenolic profile of the initially finished wine product. And in the field or the vineyard, the phenolics are part of the equation of determining grape maturity. So there are 4 groups of phenolics: the catechins, tannins, total anthocyanins, and polymeric anthocyanins. Polymeric means linked together into a polymer or a chain of these anthocyanin groups. So first, the catechins. You don't have to try to memorize the chemical structure down at the bottom here, but that is one of the catechin structures. Sometimes they're referred to as flavanols, and they're found in seeds, stems, and immature grape skins. And so when you eat immature grape skins or bite into the seeds, you get a very strong catechin flavor. A lot of catechin is not good. They typically decrease as the grape ripens, and winemaking techniques can influence the amount of extraction, which is a useful indicator of seed extraction in the finished wine. So you measure the catechin at the finished wine level, and you can get a pretty good indication from that catechin level in the finished wine how much was extracted from the seeds, because that's where most of it is going to come from, unless you had a problem with the grapes and you had a lot of hen and chicks. The under mature grapes that would potentially give catechins as well. A little bit can be a good thing. A lot of it, not good. Catechins in large quantity provide a very unfortunate flavor. Polymeric phenols and tannins, they come from the grape skins. They also come from the oak in barrels or additives. So when you're aging the wines in a barrel, or you're using oak staves, oak boards that you put in, or oak chips or oak powder, you can make the oak as small as you want. You are getting some of these polymeric phenols and tannins added to the wine with specific different variations based on the flavor. So the polymeric phenols and tannins that'll come out of an oak barrel would be different than the specific types that are going to come out of the seeds and stems from the grapes themselves, or the grape plant themselves. And so it's really important, the type of oak that you use. Are you using American or California oak? Are you using French oak? Are you using barrels? Are you using staves, which are boards, pieces of boards? Are you using chips, little chunks of wood, or even powdered wood? They all have their different extraction rates and their different tannin phenol characteristics. And then you even toast the barrels or the staves, wood boards, or the chips or the powdered wood. You toast it by putting it in contact with a flame for a specified amount of time, either a very light toast, you barely flame it, versus a dark toast where you flame it quite a bit and you char it. And again, you're changing the flavor characteristics. And as you use a barrel, you get an expensive French oak barrel. You don't just use it once, but you have to plan for it. The first time you age a wine in a fresh, brand new, expensive French oak barrel, that's going to give you a certain flavor profile. The second time you use it, the flavor profile is going to be different. And the third and the fourth, how many times are you going to use that same barrel? Talk to a winery, there's lots of opinions on that, but the amount of tannins and phenols is going to go down over time as you use the same barrel over and over again. And there's only so many uses before you're no longer getting these tannin phenolics extracted at all, or at least not in any amount that's significant. So they protect against oxidation, again, another characteristic that we've already discussed. They stabilize the color, which is important. So the color becomes more stable with these polymeric phenols and tannins. You don't want changes over time. Enhance the mouthfeel and what we call the astringency or dryness, which is part of that mouthfeel. So these polymeric phenols, and especially the tannins, in my understanding, give a very strong influence on that astringency or dryness. It is a way the feel kind of puckers you up, not in a sour way. It's different than puckering you up with the sourness of an acidity. It is puckering you up with a dryness. And it's hard to describe. Maybe somebody else on another video, YouTube video, describes it better than I do. The only real way that I know of to convey dryness or astringency is to sip two wines side by side, a low tannin and a high tannin wine, and you can go, oh, that's what you mean by mouthfeel. That's what you mean by astringency or dryness. Commercial tannin products are available, often added during fermentation to improve color. Usually decreases as the grapes mature and can account for 50% of the phenolics in young wines, and increases as the wines age. Because why would it age? Why would it change? You're not changing anything in the bottle, but chemical reactions are occurring, and some of the chemical reactions is the polymerization or the chain formation as these phenols link up. And again, that's one of the ways where you look at it, one of the characteristics, like, all right, we have a certain profile of phenolics in our wine when it's finished with our fermentation process. How long should we allow it to age based on what we're seeing to get the right flavor? Total anthocyanins are pigments in the grapes that give the red, blue, or blackish colors. They typically increase during maturation, and then they plateau and then decrease. So there's kind of this curve that they go through. Increased concentrations in mild or cool weather. So grapes grown in cooler appellations tend to have higher total anthocyanins, and grown in warmer areas tend to have a lower total anthocyanin. Again, that's one of the reasons why different appellations have different reputations, and why you might choose one variety over another depending on exactly where you're growing it. Even if the grapes will grow just fine, the anthocyanin concentrations might be better for the type of wine you're trying to grow, or the wine grape you're trying to grow, in one appellation versus another. Polymeric anthocyanins, where you have anthocyanins bound to tannin, and significantly contributes to color and color stability. Generally increases as grapes mature. Typically they don't decrease as wines age. And polymerization occurs most readily during fermentation and continues through the life of the wine. Again, the aging process, this polymerization continues during the entire life of that wine in the aging process. What determines the concentration? Things you would expect: the vineyard environment and location. What is the appellation, and specifically within that appellation, where is the vineyard? What did the vineyard manager do? What were the viticultural practices, irrigation and fertilization practices, pest control, everything. The weather and temperature, not only the general climatic patterns over the years, but what specifically happened that year and even the year before. Because remember, grapes are heavily influenced by conditions the year before, not just this year's grape growing conditions, but what about the buds that were developed and finalized the previous year? Again, very important. The winemaking technique, clearly once you have the grapes, you can make major changes based on the winemaking technique, and obviously the cultivar and the clone. So if you have a Pinot Noir, for example, there's not just one Pinot Noir, it's many different Pinot Noir clones, and even the rootstock on which you choose to graft your specific clone. So again, there's no surprise here. You need to match the variety to the vineyard. You need to make sure you're taking into account your slope, sun exposure. You need to take into account your soil type and water holding capacity. All of those things are crucial and will impact your phenolics. Sun exposure, leaf pulling. Leaf pulling can be very important, not only for disease management to keep moisture levels down inside the canopy, but you can also do leaf pulling to provide what's called dappled light, the kind of little fingers of light that move across, these little dots of light that move across the grapes as they're maturing. If you leave too much exposed and they're in the direct sun, the whole cluster's in the direct sun all day or for too much of the day at one time, you can have sunburn problems. That's not good. So you want dappled light or just little fingers coming through, but you don't want them in complete shade either. So again, canopy management, pruning, trellising, and leaf pulling all are going to influence sun exposure on the actual grape clusters, which can influence the grape phenolics dramatically. Irrigation, again, how much do you stress the vines, if you stress them at all? Typically, there is a mild stress that you want to do on red grapes around veraison to influence a little bit of flavor production. You don't want to overdo it. Fertilization, again, be very stingy on the nitrogen. You need enough, but not too much. You definitely need plenty of boron, but not too much. We've talked about fertilization, very important. Diseases, cluster thinning, and total yields. Again, if you overcrop, what happened there? If you overcrop, that gives you a change in phenolic concentrations, as well as sugar concentrations, as well as other things. And trellis type and row direction. All of those things come together and have influence, important influence on the phenolics. Weather and temperature, no surprise here, large changes in the diurnal temperature swings. Diurnal means the daily cycle. So from night to day to night to day, you go through this pattern as you go night to day from, warmer temperatures typically during the day and cooler during the night. And the larger swings can have an impact on phenolics. Excessive heat, lower phenolics. Warm days and cool nights are optimum for phenolic development. And winemaking techniques. And, there's a lot of differences here. I'm not going to go through them one by one, but each of the things on this slide will have a change, not only in total phenolics, but which phenolics. So you want low catechins, but you do want other types of phenolics. Maybe you'll remove the seeds, but leave the skins as much as possible. You can do that. There are lots of different techniques and tricks you can try to do to influence your phenolics in your winemaking techniques. So how are they measured? Samples collected from the vineyard weekly. And so they'll take 3-gallon bag clusters. This is what they do at Scheid Vineyards. 3 1-gallon bags of clusters collected from each block every week to analyze what's going on. So that's a lot of fruit, but they're a big operation. So, you know, they got a lot of grapes going into that winery. And the samples are sent to ETS Labs. That's the lab that they were using. I think they're still using it. My ex-wife actually works there, so I've heard her talking about ETS Labs not too long ago, so I think they're still their go-to lab. And they crush the samples, they extract the juice from that crushed sample, and there is an extraction process done in the lab, and they'll analyze it for the various types of phenolics. And so here is an extraction lab setup. This is obviously several years old. That's an ancient monitor, but not a whole lot has changed. Some of the machinery is a little more sophisticated and accurate and less expensive than it was. But other than that, the basics are the same. You crush, extract, and develop a report, a data analysis report. And there are different varieties that are going to have different profiles, and I'm not going to take any time. I don't think it's important right now for the purposes of this class to go through the different types of varietal specifics. I do have some data with these that I normally bring up if I'm live in the classroom, but I can't do that here. The data is proprietary. I'm not allowed to share it with the class. They don't care if I bring it up on the screen on a non-recorded video in a classroom and just talk about it, but I can't do it here now because this is being recorded in a permanent way. So gotta skip that.